Hi there, Mr. Sutton here, bringing you the Algebra 2 3-3 lesson on completing the square. In this one, we will be solving quadratic equations using square roots, which we've done a little bit of before. We're going to up our game, though, and we're going to solve equations using a process called completing the square, which is going to actually allow us to solve any quadratic equation that we want. And for the honors version of this lesson, there's an extra topic in here of applying completing the square to write quadratic functions in vertex form. So let's get going. For our first example, we've got a problem that they're telling us to solve this equation using square roots. Now, you might be thinking when you look at this, hey, we've got just a 1x squared. I wonder if I could just move the 100 over to the left side, when in doubt, zero it out, and solve it using just regular factoring. And you probably could. However, they said solve using square roots, so how might we apply square rooting to this situation? Well, here's the thing. On the left side here, you might have noticed that we've got two perfect squares, and if you dug a little deeper, you would see that this is a perfect square trinomial. If you already have a perfect square trinomial on one side, something in the form of a squared plus or minus 2ab plus b squared, and that 2ab part is a little tough to pick out. But if you think it's there, then what you can actually do is factor it, because this will turn into a squared parentheses, and then solve it by square rooting. So with that in mind, pause the video and try that. All right, so here's what I had in mind. So we know that this particular format can be turned into a plus or minus b, whatever the sign of that middle term is, quantity squared. So over here, we take the square root of the x squared, that's x. Square root of 64 is 8, and we keep that middle sign, so this is going to be x minus 8 quantity squared equals 100. And now that I have this squared parentheses, I can just square root both sides and go from there. So the square root of the left side is going to be just x minus 8. On the right side, don't forget the plus or minus, because we're square rooting an equation, so plus or minus 10. And then I can move the 8 over to the other side to get x by itself. Now just one other little thing here. If you are able to combine the numbers on either side of this plus or minus, then you're supposed to do that. So if we do 8 minus 10, that's going to be negative 2. And 8 plus 10 gives us our other answer of 18. So the little trick we just used on that last example of turning something into a squared parentheses and then square rooting it, that only works if you have a perfect square trinomial. But what if you don't? What if you're missing a piece, like this x squared plus 14x plus 0? At this point, we could not factor this into x plus or minus anything squared. So how can you convert this into a squared parentheses so that you can still use square rooting? Well, the process that we're about to follow here is called completing the square. We're going to complete the perfect square trinomial. And it turns out that there's a magic number you can add over here that will allow you to do that. Now, where does that number come from? Well, since a perfect square trinomial is a squared plus 2ab plus b squared, this middle term here is 2 times a times whatever the b that you're supposed to square is. Since the a over here is basically just this 1 times x kind of deal, the b is whatever you're going to have if you divide this middle number by 2. So our process for getting our magic constant here is going to be to divide this b value by 2, and then to actually get the value over here, to get the b squared in the perfect square trinomial, we have to square it. So here's my general formula, b over 2 squared. b is 14 in this case. It's whatever your linear coefficient is. So that's 14 over 2 squared, or 7 squared. Or if we simplify it further, we can just add 49 here. And we have now completed the square. Now, since we've completed the square, this is automatically in that a squared plus 2ab plus b squared format. So we can automatically just square root the first and last thing and stick those in the parentheses. So we're going to have x, and the square root of 49 is 7, so x plus 7 squared, and that is it. I mean, if you want to double check, 2 times x times 7 does give you 14x. So now that we've seen the process of completing the square, it's just 2 quick steps here. We're going to go ahead and pause the video and have you try this next one on your own. See if you can complete the square for this expression and then factor it. All right, let's see how that went. So we're doing, again, b over 2 squared, so negative 12 over 2, square that. That's negative 6 quantities squared, which I can just write, if I add it over here, as 36. And then this is just going to factor into y minus 6, the square root of 36 quantities squared. All right, we're going to have you try one more just to make sure you've got the hang of it. This one has a little bit of a curveball in there. Pause the video and see if you can adjust to the new situation here. So if we do b over 2 squared, this time we see that that's going to be 9 over 2 squared. Which, what is 9 over 2 squared? Well, we're going to have to just leave the 2 in there unless you want to convert this to a decimal. But if we square that, that's going to be 81 over 84. And then factoring this, the square root of 81 over 84, you actually had it in this squared parentheses already. You're just going to have x plus 9 over 2 quantity squared. If you're taking the Algebra 2 non-honors version of this lesson, this last example was actually the end of part 1. So if you're taking that course, you can pause the video and try out some practice problems dealing with solving by square rooting and just completing the square with an expression. If you're doing the honors, then keep on going. We're going to see how to do this to solve an equation. Welcome back. If you're doing the non-honors version of Algebra 2, if you're doing the honors, then hey, thanks for sticking with us. We're going to now use this completing the square process to actually solve one of these equations. So to start this one off, first off, there's a situation that we like to be in. You'll notice that we have just a 1x squared and a plus or minus a bx kind of situation and nothing else on one side of this equation. Given something in this 1x squared plus bx form on one side, here's what we can do. First thing we can do is complete the square, specifically for the stuff on the left side here. So actually pause the video and see if you actually can complete the square for the stuff on the left. Just get it down to that squared parentheses format. All right, let's see how that went for you. So I'm going to rewrite this with a little more space so I can add my mystery constant in there that will complete the square. So as we've been doing, we just take half of this b value and square that. So we have negative 4, square that, and now we're adding that to the left side. Here's the other piece. Because you're solving an equation, since you're solving an equation now, we can't just change the value of one side and get away with it. We have to change the value of the other side by the same amount. So make sure you add this b over 2 squared piece to both sides, not just the one side. So adding this plus negative 4 squared piece over there, now we can actually factor the left side. Now you'll notice that I didn't just immediately convert this into 16. I could have, but if you leave it in this squared parentheses, it makes it easier to see what's going to be going in your squared parentheses when you factor this. Like this on the left side, we're just going to have x minus 4 quantities squared. And then on the right side, just to kind of finish my thought, I can simplify this if I want, so negative 10 plus 16. All right, so we've gotten to this point, and what now? Well, you've got a squared parentheses on one side. You have a little bit of cleanup to do on the other side, but you're pretty close to having only one thing over there. So at this point, after you've completed the square and factored, just solve by square rooting, just like we did on the very first example of this lesson. So pause the video and just see if you can take it the rest of the way here. All right, so let me clean up that right side. That'll be just 6 over there. Square rooting both sides, I end up with x minus 4 equals plus or minus square root of 6. I can't really simplify that anymore, so I'll just leave that the way it is. But I can add this 4 over to the other side, which gives me 4 plus or minus radical 6. And since I can't really combine 4 and radical 6, I get to just leave it in that format. For this next problem, we've got a few issues if we're trying to solve this by completing the square. In the last example, we had 1x squared plus an x plus nothing else on the left side equals whatever. In this one, we've got a little more going on. We have a 5 instead of a 1, so we need to deal with that. We also have this 30 that's on the left side. So if I'm looking to add in some mystery constant and there's already a constant there, I'm going to have to do something about that or factor it in. So a couple things you want to do before you actually go to the process of completing the square. One of those is you're going to want to clear out this constant here so you don't have to worry about what's already there when you add in your mystery constant. So I'm just going to move this 30 to the other side by subtracting. No big deal. The other thing we're going to want to do is this a value that's not a 1, we're going to want to divide everything by that. And we're going to do this no matter what the consequences. I mean, in this problem, everything is neatly divisible by 5, but even if it weren't, we would still divide by that a value. So that's going to give us x squared minus 4x equals negative 6. And now we're back to that situation where we have like x squared minus bx sort of thing. So at this point, since we're back to what we were on the last problem, pause the video and see if you can take it the rest of the way. All right, so completing the square now, I'm taking half of my b value, that's going to be negative 2, and I'll square that and add that to both sides. So on the left side, I've got x minus 2 squared, and on the right side, I can simplify that to be a plus 4. Going a little bit further on the right side, negative 6 and 4 gives me negative 2. And now I'm ready to solve by square rooting. So on the left side, I've got x minus 2. On the right side, I have a plus or minus square root of negative 2, which I can make plus or minus I radical 2. And then as one more thing, I'm just going to add 2 to the other side. So 2 plus or minus I radical 2. So this completing the square process, it takes a little bit of work, but this is getting us answers that just solving by regular square rooting, we couldn't have done that here because of this x. And solving by factoring also wouldn't have worked, not if you're getting irrational imaginary numbers out of this. So this is a pretty important process to have if you want to be able to solve anything. There is another way to do it, but we're not there yet. At this point, with the conclusion of this example, if you're taking the non-honors Algebra 2 course, this is the end of the lesson. You can turn off the video and move on to other things. If you're doing the honors version of the course, then this is the end of part 1, and there is another part 2 waiting for you. See you then. Welcome back if you're doing the Algebra 2 honors course. If you're not doing the honors course, then hey, feel free to tag along. This is going to be kind of wild. So we've got another completing the square problem in store for you. We start this one kind of like we did the last one, right? We have this constant here that we want to get rid of. We want to divide everything by 2, so let's do that. So subtracting 5, there we go, or adding 5 rather. And then dividing everything by 2, we've got x squared plus 3 halves x equals 5 halves. And already things are looking a little bit suspicious, because if we're looking to take half of this b term, well, what's half of 3 over 2? So there's a couple ways you could do this. Probably the fastest is just to multiply this by 1/2, or you could think of that as doubling the denominator, or having the numerator. There's a lot of different ways to go about it. I said to take half a fraction, double the denominator. That will always work, but you may have to reduce it after you do that. So with that in mind, see if you can take this problem the rest of the way. This one's a little bit messy, but hey, I think we're up for the challenge. All right, so my b value that I'm going to be squaring, doubling my denominator, that's going to be 3 over 4. So I've got 3/4 squared that I'm adding to both sides now. That looks like a bucket full of fun. So on the right side, factoring this, that's just going to be x plus 3 over 4, quantity squared. On the right side, I'm going to start simplifying this. So I can write this as 5 halves plus 9 over 16. And I'm going to have to clean up that right side a little bit more. 5 over 2 is equivalent, if I multiply by 8 over 8, to 40 over 16. 40 over 16 plus 9 over 16 gives me 49 over 16. And now I can square root both sides. That gives me x plus 3/4 on the left. And hey, these are both perfect squares. That's going to be 7 over 14 plus or minus that, or 7 over 4 rather, plus or minus that on the right. Okay, subtracting the 3/4 to the other side, that gets us our x all by itself. And now I can get 2 answers out of this. in whatever order. If I do negative 3 plus 7 over 4, that's going to be 4 over 4, which is just 1. And if I do negative 3/4 minus 7/4, that's going to be negative 10 over 4, which I could reduce if I wanted to negative 5 over 2. So the funny thing is, this one actually could have been solved by factoring since you ended up with rational answers, but you don't always know that going into this. For the next couple problems, we're doing a specific application of completing the square. Namely, we want to write this quadratic in vertex form and then identify the vertex. So yes, there are other ways you could find the vertex. You could use negative b over 2a and go about it that way. But what if we want to convert it directly into this a parentheses x minus h squared plus k form? Because this is a nice form if we want to do some transformations with it or something like that. So in order to go from this form, standard form, to this form, one thing we're going to want to do is complete the square. We need to get one of these squared parentheses. So we're going to complete the square specifically for this x squared minus 12x piece here. Once we've completed the square for that, then we're just going to go and solve for y. And then once we've got y by itself, it'll actually be in this form if we've gotten it to where we can factor it into this squared parentheses. So give it a shot, pause the video, see how far you can get with this, and then we'll bring it back together to see those steps. Alright, so I'm going to focus on x squared minus 12x. That's my x squared minus or plus bx part of this that I'm completing the square for. Writing these parentheses doesn't do anything functionally in this particular problem, but it does tell me that, hey, this is the stuff I'm going to focus on for completing the square. I'm not going to worry about this 18. It's kind of separate. So if I'm completing the square, half of negative 12 is negative 6. So I'm going to add negative 6 squared to both sides of this equation. On the left side, that gives me y plus 36. I'll just go ahead and simplify it now, because why not? On the right side, well, the whole point of completing the square was so that I could turn this into one of these squared parentheses. So this is going to be x minus 6 squared, plus that 18 that's still hanging around. And now we just have to get y by itself. So subtract 36 over to the other side, and 18 minus 36 is negative 18. And if we want to actually identify the vertex, remember that's just going to be h comma k out of that mess. So in this case, we've got 6 comma negative 18. For this next problem, this is a little bit trickier than the last one because we have a 2x squared here. We're still going to try to put this in vertex form though. So if you don't immediately have x squared plus or minus a bx, then you may need to take out a GCF to get that, to get the x squared plus bx. So in this case, we really just take out whatever is next to the x squared, whatever that a value is, factored out of those first two terms. So we have 2 parentheses, and then we'll have an x squared and a minus 4x, and that's all that I'm going to factor that out of. I'm going to leave that negative 13 all by itself over there because, again, you know, that's probably going to contribute to the plus k in our vertex form. So at this point, completing the square, well, half of negative 4 is going to be negative 2. So I'm going to take negative 2 squared and add that to both sides, kind of, sort of. And I'm about to add something to the left side with this f of x. But here's the thing. When I add this plus negative 2 squared business inside this parentheses, that means that I'm not really just adding plus 4. I'm adding whatever is outside this parentheses times that, because this 2 gets distributed to everything in here. So you do need to remember to multiply your GCF that you took out in the beginning by whatever this b over 2 squared piece is when you add this to the other side. So with that in mind, pause the video and let's see if you can go the rest of the way and get the vertex form and the vertex. Alright, so what I have to add over here then is not just negative 2 squared. It's going to be 2 times negative 2 squared. Now that I have this in mind here, I've got f of x plus 2 times 4, which is 8. And over here we've got 2 and then x minus 2 parentheses squared. minus 13. And just my last step of subtracting 8 to go over there. So that's going to be 2 parentheses x minus 2 squared minus 21. And then the vertex out of that, we've got 2 comma negative 21. And that's it. So that's it for our lesson on completing the square. You now have the ability to solve any quadratic formula in all of existence. You're welcome. Till next time, Mr. Sutton signing off.